Okay, let's start the pre-calculus. Unit 1. Okay. Introduction, and we got. Okay, let's do this.
Of other functions, or so we have three different function definitions here. This is f of x in blue. Here we map between different values of t and what g of t would be. So you could view this as a definition of g of t. And here we map from x to h of x. So for example, when x is equal to 3, h of x is equal to 0. When x is equal to 1, h of x is equal to 2. And actually, let me number this. 1, 2, 3, just like that. Now, what I want to do in this video is introduce you to the idea of composing functions. Now, what does it mean to compose functions? Well, that means to build up a function by composing one function of other functions, or I guess you can think of nesting them. What do I mean by that? Well, let's think about what it means to evaluate. What does it mean to evaluate f of, not x, but we're going to evaluate f of, actually, let's just start with a little warm-up. Let's evaluate f of g of 2. Now, what do you think this is going to be? And I encourage you to pause this video and think about it on your own. Well, it seems kind of daunting at first if you're not very familiar with the notation, but we just have to remember what a function is. A function is just a mapping from one set of numbers to another. So, for example, when we're saying g of 2, that means take the number 2, input it into the function g, and then you're going to get an output, which we are going to call g of 2, g of 2. Now we're going to use that output, g of 2, and then input it into the function f. So we're going to input it into the function f. We're going to input it into the function f, and what we're going to get is f of the thing that we inputted, f of g of 2, f of g of 2. So let's just take this step by step. What is g of 2? Well, when t is equal to 2, g of 2 is negative 3. So g of 2 is negative 3. And so when I put negative 3 into f, what am I going to get? Well, I'm going to get negative 3 squared minus 1, which is 9 minus 1, which is going to be equal to 8. So this right over here is equal to 8. f of g of 2 is going to be equal to 8. Now, what would, using that same exact logic, what would f of h of 2 be? F of h of 2 be? And once again, I encourage you to pause the video and think about it on your own.
H of 2, hx, y, got the x-axis, so you got 2, but what is the h? Yes, got the x, it's 2, and the y is 1. So when x is 2, y is 1. So wait. When y h of 2, it doesn't say how this is h of 2. When y, where's the h? When does y equal h2? h2, x is 2, y, x is 2, so y is 1. So let's suppose this is going to be 1f, 1 squared is 1, minus 1, 0. Yes.
Well, let's think about it this way. instead of doing it using these kind of this little diagram, here everywhere you see the input is x. So whatever you do with whatever the input is, you squared and minus 1. Here the input is h of 2. And so we're going to take the input, which is h of 2, and we're going to square it, and we're going to square it, and then we're going to subtract, and we're going to subtract 1. So f of h of 2 is h of 2 squared minus 1. Now what is h of 2? When x is equal to 2, h of 2 is 1. So h of 2 is 1. So since h of 2 is equal to 1, this simplifies to 1 squared minus 1. Well, that's just going to be 1 minus 1, which is equal to 0. And we could have done it with the diagram way. We could have said, hey, we're going to input 2 into h. Input 2 into h. If you input 2 into h, you get 1. So that is h of 2 right over here. So that is h of 2. And then we're going to input that into f. And then we're going to input that into f, which is going to give us f of 1. F of 1 is 1 squared minus 1, which is 0. Which is 0. So this right over here is f of h of 2. H of 2 is the input into f, so the output is going to be f of our input. F of h of 2. Now we can go even further. Let's do a composite. Let's compose three of these. Let's compose three of these functions together. So let's take, well, I don't know, let's take g of, and I'm doing this on the fly a little bit, so I hope it's a good result. G of, and let me switch the order. G of f of 2. And let me just think about this for 1 second. So
G of f of 2. So I got f of 2, that's 4, minus 1, 3. So G of 3, which is 4.
That's going to be G of f of 2. And let's take h of g of f of 2, just for fun. H of. So now we're really doing a triple composition. So there's a bunch of ways we could do this. One way is
H4
to just try to evaluate what is f of 2. Well, f of 2 is going to be equal to 2 squared minus 1. It's going to be 4 minus 1, or 3. So this is going to be equal to 3. Now what is g of 3? G of 3 is, when t is equal to 3, g of 3 is 4. So g of 3, this whole thing is 4. F of 2 is 3, g of 3 is 4. What is h of 4? Well, we can just look back to our original graph here. When x is 4, h of 4 is negative 1. So h of g of f of 2 is just equal to negative 1. So hopefully this makes you somewhat familiar with how to evaluate the composition of functions.
Actually, this is a review to me. So precalculus is a review to me because I need to review all the mathematics stuff for my future endeavor. So let's go to, this is an article. Cam is a farmer each year. Cam is a farmer. Each year he plants seeds that turn into corn. The function below gives the amount of corn, C in kilograms, kg, that he expects to produce if he plants corn on a acres of land. So CA equal 2500A minus 1500. Okay. For example, if Cam plants 2 acres, he expects to produce, so this is going to be 2, and the rest. Okay. What Cam really wants to know how much money you will make from selling this corn. So he uses the following function to predict the amount of money M in dollars that he will earn from selling C kilograms of corn. So MC is the kilograms, okay, minus 50. So it can produce 13 kilograms. So that's gonna be, let's say, 0.9 in the amount of kilograms minus 50, that's 12. Okay, 1200 and $100. Notes that CAM has two separate functions to get from acres planted to expected earnings. This function C takes acres to corn, while the second function M takes corn to money. So, yep, yep, yep. So this is gonna be M C A. Okay, wouldn't it be great if you could write it that term? Goes directly into expected earnings to creating a new function MCA. Okay, so to find a general rule that converts acres into expected earnings, but just how do we do this? We'll notice that the expression and the input of function m. So to find this expression, we can substitute CA in for C function m. So got MC equal and MCA equal 9 and CA minus 50. Okay, so I got okay, okay. So the function it gets blended directly into expected earnings. This new function. Wait. So the function MC. Wait. What did he do? MCA. Where is 700 A minus 1500. Okay, minus 1500, which is equal 50. We're gonna multiply 0.9 here and 0.9 here. So we got 750A minus 1350 minus 50. And then we minus the 50 here. Oh wait. Something is wrong here. What do you mean? This is the same, but this is minus 50 is 1300, not 1400. It's 1300. What do you mean? What do you mean 1400? Minus 50, that's 50, that's 1350 minus 50. That's a 1300, not a 1400. So the function converts planted directly. There's something wrong here. 1500. 1500. So I get 0.9 multiplied by 7500, 7500, 675, 6750, 6750, 6750, and then 0.9 minus 50, sorry, multiplied by 1500, that's 1350, again 1350 minus 50, that's 1300. It can't be. What happened here? This is 1300. Let's check it out. It's 1400. Give 1200. Okay. Test it. Get 1300. 500. Okay, I get 0.9 multiplied by 1300, 500 minus 50. That's 1200. So we should get 1200. So let's do this. 6750 multiplied by 2 minus 1400. That's 1200. $1,400. 1200. ايوه شغالة والله بكيفش. 1200 What happened here? It can't be. This can't be. Okay. Note the minus. Note the minus. So minus 1350 and minus 50 and minus 50. Minus and minus. Minus and minus. So it's 1400. Am I correct? It's 1400. Minus 1350 minus 50. Yep. Wait. Minus 1350 minus 50. Yep, minus 1400 because minus 5 and minus 5 minus 10. While 5 minus 5 is 0. It's minus 10. And minus 50. Yep. Correct. Defining com- composite functions. We just found what is called a composite function instead of substituting acres planted. Okay, we did this by substituting C, finding C. We now know that opposed with C. We did this by is important. We just found a composite function instead of substituting acre planted into the corn function and then substituting the amount of corn produced into the money function. We found a function that takes the acres planted directly to the expected earnings. We did this by substituting CA into function M or by finding MCA. Let's call this a new function, M composite C, which is read as M composed with C, M composed with C. We now know that M composed with C, A equal MCA. This, in fact, is the formal definition of function composition. Visualizing visualizing the two methods. Here's the visual to interpret the above two. Okay. Using both functions C and M, function C, the corn function takes 2, then function M, function takes 2. Using the composites function, we see that function M composed with C takes, composed with, am I correct? Composed with C takes 2 directly, takes, well, it's supposed to be TO, takes 2 directly, takes 2 directly to 2, the number 2 to 1200. 1200 and 100. The two are equivalent. Now let's practice some problem using the function presented in the example. How much can Cam expect to earn if he sells all the corn produced on 1.5? For reference, C 7500. 5. So what we're gonna do is we're gonna MCA. So this is the CMA. Here's MC. We're gonna multiply. We're gonna plug it here on the C. So 0.9, 0.9 in the 7500. 0.9 over 7500 acres of multiplied by 1.5, that's minus 500 minus 500, that's all minus 50. It's going to give me 8725, 8725 Check. Okay. Problem 2. Ben is a potato farmer. Should we? Okay, I guess. Gonna need the Ben here. Ah, it's cold. Oh, please, come on. Okay. Got Ben is a potato farmer. The function PA, get this function here, PA equal 2500, 25,000, A minus 1000 gives the amount of potatoes. Okay, so this P is the amount of potatoes in kilograms. Amount of potatoes is 1. Amount of potatoes in kilogram that he expects to produce from planting potatoes on acres of land. So this is acres of land. The function planting potatoes on acres of land. So the function MP, now we have another function, MP equal 0.2 minus 200 gives the amount of money. It's money. Oh my God. Money. Okay. Amount of money in dollars that Ben expects to make if he produces P kilograms of potatoes. If he produces B kilograms of potatoes, which is this one, am I correct? Amount of potato in kilograms. Yep. B is amount in kilo of potato. Okay. How much money can Ben expect to make if he sells all of the potatoes produced on the 3 acres? How much money can Ben expect if he sells all of the potatoes produced in 3 acres. So we could do this in 2 ways, but we were going to do it. We're going to plug it. So we got P, not really. We got M, P, A equal. This doesn't make sense. This formula doesn't make sense. There's no way we can plug anything here. It says 2P. 2P here. P. So 0.2 in PA, which is 25,000 A minus 1,000, okay, minus 200, minus 200. So it's going to be something like this, 0.2 over 50, 25,000 A minus 1,000 minus 200. My God, I hate this pen. Minus 200, and then gonna come here, this and this, and this. So got 0.2 multiplied by 25,000. It's 5,000. You get a 5,000 A. Don't forget the A. And minus, I got 0.2 over that's a minus 200. It's a minus 200 and minus 200. This will no, not cancel. Sorry. Take the by stroke. Delete stroke. Get this one. So it's gonna be 5,000 A minus 200 and minus 200 minus 400. So when we plug in 3 acres, it's gonna be 5,000 multiplied by 3 minus 400, which is gonna be 15,000. 15,000 minus 400, which is gonna equal wait, 14,000 and 600. 600. Guess 15,000 plus 400. Yep, 14,600, 600, and 600. So I'm gonna go here. Let's see, 14,600. That's a 14,600 check. That's correct. Problem theory. Which of the following expressions give the amount of money that Ben expects to make if he plants potatoes on A acres of land? It's this one. Am I correct? So we have 5,000 A, 5,000 A. And this is where we get it. 5,000 A minus 400. 5,000 A minus 400. Checks. What do you mean? It's correct. So I got all three questions correct. Let's go to the next article. Given two functions, we can combine them in such a way so that the outputs of one function becomes the inputs of the other. This action defines a composite function. Let's take a look at what this means. Evaluating composite functions. Example, given two functions, we can combine them in such a way so that the outputs of one function becomes the inputs of the other. This action defines composite function. Let's take a look at what this means. Evaluating composite functions. If fx equal 3x minus 1 and gx equal x squared plus 2, then what is if j3? So what we have, I'll try my best, given that it's been a long time since I had studied any math. This is refreshing my memory. Fx equal 3x minus 1 and gx equal x cubed plus 2 if g3. So what we can do is plug this here. So if gx equal 3 on x cubed plus 2 minus 1, which gives 3 g equal to 3x cubed plus 6 minus 1, and this is going to be 3x cubed plus 5, and by plugging the 3 here, it's going to be 3 over 3 cubed plus 5. So 3 cubed is equal to 27. So this is going to be 3.27 plus 5 multiplied by 3. It's going to be 81. 81 plus 5. That's the product. This is the product, not in math. It's a product. It's not a comma or decimal. Okay, so I got 81 plus 5. That's 86. This is my solution. Let's check. Okay, plugs it. Let's get in it. 86. That's it. Follows that. Okay. Okay. Finding the composite function. Composite function that takes you example and G3. It's gonna be which is what we just did, 3x squared plus 5. That's what we just did here. Here. What do we have? Where do we have it? Here it is. 3x q all to the power of 3 plus 5. Got it? This new function should take 3 directly to 86. And let's practice problem 1. Fx gx equal x squared plus 2. Let's get it. So I got the fx equal 3x minus 1. Get the gx equal x cubed plus 2. And I get gf1. Okay, so I got the gfx, so here gfx equal, here we got 3x minus 1 all to the power of 3 plus 2, and then I got them equal 3x, first 3, here is where I got 3 over 3. Wait, do you know how to do this? We can actually test this. We can actually test this. If we say 2, we can actually test this to check the rules does it apply. So we got 2 product of 4 all to the power of 3. Okay, so what are we gonna do? We usually take the products 2 and 4, that's 8 to the power of 3. But what if we took it to 2 to the power of 3 multiplied by 4 to the power of 3? Would it still be the same? So that's 8, 2, 2, 2. 2 multiplied by 4 by 2, that's 8. Multiplied by 4, 4 over the power of 3, that's 46, 64, that's 500, that's 512, where is 8 over 3, that's 5, 12, equal 5, 12, can you believe it? 12, 5, 12. So this checks in, this checks in. So what we need here is to actually make it 3 over 3, 27. So this is wrong. I'm gonna delete this stroke. Go back. It's not 3, it's 27. X cubed over minus 1 minus 1 minus 1 cube is minus 1, so it stays minus 1 plus 2, which gives I'm gonna delete our method of checking whether we should cube the number before the x or not. It turns out we should. Okay, so we got 27 cube x cube minus 1 and plus 2, that's a plus 1. I get this. So what is he actually asking? If this is 1, so 1 cube is 1 over 27, that's 28. Let's check our answer. That's 21. Oh my god, what did I went through? What if it's 3? Is it 4? Okay, let's check. Okay, 1 over and 3, that's 3 plus 1. So this is 3. 3, it's 4, let's check if it's 4. 28, it's not 21. Oh my god, 28. Still is, so we'll go with 4. Doesn't check in. This is 3x. This is 3x. What are we having here? 3x minus 1. So I got 3x minus 1 over 3 plus 2. What do you mean? So this is I got 3x product of 3x product 3x. So I got 3x over 3x, that's 9x square 3x 3 over 9, I think 3, that's 20, that's 29, 27 x cubed. So what are we having here? And I got this minus 1 cube minus 1 cube, that's minus 1 and minus 1 and plus 2, that's a plus 1, so this checks in. What are we having in the triple? F1. Are you saying that this x is not the same as this x? So it's going to be here 3 minus 1, that's 2. 2 here, 8 plus 2, that's 10. Why isn't this checking out? Why isn't this not? This is not going to check out. Say the answer is 10. But why isn't this checking? I want to see. For x equal 1. X equal 1, which is what I'm interested in. Get G of x. Swear to God, I cannot find this. Get G of f x equal, what I have is here 3x minus 1 all squared plus 2. So what do I have? This is not how it is. This is actually more deeper than that. This is 3x minus 1 product of 3x minus 1 product of 3x minus 1. So what's happening is 3x of 3x is 9x squared, then I got minus, and then I got 3x of minus 1, and that's a minus 3x, and I got minus 1, that's a minus 3x, minus 1 and minus 1, that's a plus 1. Am I correct? Let's check. Where is 1? My math is fucked right now. So I got this here. Probably need algebra. Need to go back to algebra. Even 3x minus 1. So I got 9. I got this. The light side. Get an easier way. Go here. Go 3x minus 1 over. So, and this is actually can go simpler because minus 3x and minus 3x is minus 6x. So I got 9x minus 6 plus 1 over 3x plus 1. Oh. Add space, please. So what am I having? Piece of paper. We have here 3x plus 1, 9x squared minus 6x plus 1. Okay, 3x, 9x squared, that's 27x cubed, 3x minus 6, that's minus 18, I guess, x, and 3x plus 1, that's 3x. You got minus 1 of minus 9x, that's minus 9x squared. I got a minus 1 over minus, that's plus x minus 1 and plus 1, that's minus 1 still, 1, so minus 1 still. So what I got the 27x cubed, there's no other one. I get the minus 18 squared and the minus 9 squared, so minus 18 minus 9, that's minus 27, minus 27x squared, and I got 3x and 9, that's 9x, and I got minus 1. Let's plug the 1 here, see if this checks. 27, 1 cubed minus 27 over 1 squared plus 9 over 1 minus 1. So 1 squared is 1, so that's 27, minus, here is also 27, here is plus 1, plus 9, here is minus 1. So what is it going to be? 27 minus 27, that's a 0, that's a 0, plus 9, minus 1. It's 8. Is it 8 or 10? What was our answer? 10. It's not gonna work. God damn it, there's something wrong. Wait, 27. Got a problem with my. Where did I go wrong? 27x squared cubed, that goes in. Minus 18 and minus 9. That's a minus 27. Minus 18 minus 18 minus 9. That's a minus 27. So what I still got is plus 3 and plus 6. That's 9x minus 1. Something wrong here. 3x and 3 and 9 is 27. Something here. What do you say? Thank you. 9x squared. Minus 3x. I got minus 1 minus 3x. Minus 1 minus 1. Minus 1 over minus 1. That's plus 1. I mean, multiplied by minus 1. That's a 1 plus this checks out. So I got, so yeah, 3 and minus 3, that's minus 6x plus 1. Okay, 6x and x, yep, plus 1. You get 3x, 9x, that's 27. That's a 27 square. 3x and minus 6. It's a minus. We multiply it by 6. It's 18. It's 18x square. 3x and plus 1. That's a plus 3x. And then I got a minus. Here that's a minus. Nine x square. That's a plus 6. Goes minus minus. That's a plus 6 x minus or minus. That's a plus 1. Okay, what I have here is minus 9 to minus 18. Minus 9 and minus 18. It's a minus 27, so I got 27. 27 square. 27 x square x cubed, and I got minus 18 and minus 9 minus 27 x square, and I got 3x plus 6x, that's a plus 9x, sorry, it's plus 9x plus 1. Is it the same? Plus 9x plus 9x minus 1. Okay, I'm gonna do this using AI to check my solution. So yeah, what I have here is this. I got this was checking for future lessons. Good thing stopped here. So I got this. Keep it here. I got this over here. Plus 2. You see where did we go wrong? This plus 2. We forgot this. So what we did is this. We did this, multiplied it, and then multiplied everything here, and this. And what we got eventually is this formula, 27 cubed plus 9x plus 2. This all is this part plus 2 plus 2. So here it's actually where did we get this plus 1 minus 1 is actually also plus 2. So that's wait, yeah, here plus 2 plus 2. So the formula is gonna be you see what we doing wrong? It's because you know what we had wrong? Because we didn't open this fully like this and so when we went through. So we saw all of this and we forgot here. So what's happening is that 27x cubed minus 27x plus 9x minus 1 and plus 2, that's a plus 1. So eventually if we plug in here 1 1 1, it's going to be 27 minus 27 plus 9 plus 1. It's going to be 10, which is correct. So we're going to test our where did we go wrong. We're going to take this. We're going to say g of f of x equal, I don't think we need this anymore, but this is how it is. So this is it. Check. You see, minus 1, then add the 2. You see, we forgot the 2. That's 1. So the correct answer is 27x cubed. We forgot the 2 here. Remember, we got to this one. Then we forgot to add the 2, which adds up here, gives us 27x minus 27. 20x cubed minus 27 squared plus 9x plus 1. Your handwriting is little hard for me to read exactly on the middle terms, but that's the target to match against. And to check your vision term by term against this. Now I got it right. So going back to not here. Yeah, okay. Problem 2, mx, nx. Okay, let's do this properly. Page. Okay. Let's write it down. M x 3 comma. What the fuck? So x equal 3x minus 2, and then I got n x 4 m n x. So m n x equal m 3x is 3x plus 4 minus 2, which is 3, which is equal 3x 3 and 4 plus 12 minus 2 minus 2, which equals 3x plus 10. Let's check. What does he want? How to write it here? Is it 3x plus 10? 3. Do you have an x? X plus 10. Check. Okay. Okay, composite function, a formal definition. In the above example, we find that in general, to indicate function f composed with the function g, can write okay, okay, okay. Now let's look at another example of this new definition of mine. Takes fg multiplied by x. Multiplied by x. Okay, now let's look at another example with this new definition of mine. Gx x plus 4 hx equal x 2 minus 2x. Find okay, we're gonna do this. Okay. Pen j x equal x plus 4. Then we got h x x squared minus 2x. Then we got h g over x and h is 2. So what do we have here? This is the composite with, excuse me for a minute. You'll have to excuse me for a second. Oh, so is this the composite? We're getting near the end of this session. It's actually good. So what do we have? Wait. Composite functions, a formal definition. Composite function. Okay? In general, to indicate the function f composed with function g, we can write f as f composed with g. This composition is defined by the following. F composite of g, so with g of x equal fg x. Okay? In between fg. So x, fg, fgx. This is this. You didn't add anything, except it's written now this way. This way. So what do you want? As he wants. Okay. How did we do it before? Remember how did we do it? Okay. What do you mean? Okay, we're here. Okay. Let's put a line here. Okay. So what do we have here? So H composed with G of X equal H G X equal X plus 4 everything squared, then minus 2 over or multiplied by x, or the product of x plus 4, and we got here so this is the left, so we got x plus 4 multiplied by x plus 4 multiplied by, we would say, minus 2 over, so minus 2x minus 2 minus 2 dot multiplied by x is minus 2x minus 2 multiplied by 4, that's minus 8. So what do we have here? X and x, that's x square, x and 4, that's plus 4x, and we got 4 and x, that's plus 4x, and we got 4 and 4, that's plus 16 minus 2x minus 8, which gives x squared plus and plus 4, that's 8x minus 2x, that's plus 6x plus 16, and this is our formula right here for the first part of the question. We got the other part, which is in minus 2, and minus 2, we just plug the minus 2 over here, so it's going to be minus 2 square plus 6 over minus 2 plus 16. That's 4 plus minus 12 plus 16. So 4 minus 12, that's a positive 4, and minus 12, that's a minus 8. Minus 8 plus 16 plus 16 equal 16. Minus 8 and plus 16 is equal to 16. So it's the answer to the second part. So let's see. Follow x. Where's our first? X squared plus 6 plus 8. That's our first one. Actually, the second one is wrong. Wait. I mean, minus 2. The plus 16 here, and the minus 2, and the minus 8. We forgot the minus 8. So here it's going to be minus 8. Always forgetting something. Minus. You see? Plus 16 minus 8. Minus 8. That's x squared plus 6x plus 8. That's correct. This is our. Okay. So it's equal 0. Yep. Of course, we could also have found. Okay. Okay. Let's practice some problems. We got a problem here. Let's hope I get it right this time without any mistakes. I got fx equal 3x minus 5. I got gx equal 3 minus 2x. Formally evaluate g to f over 3 composed with f. So we'd say, okay, it's a g f equal g fx equal 3 minus 2 over 3x minus 5, which will take this, so it's going to be equal 3 minus 2, this is minus 6, x minus 2 minus 5, that's plus 10. Right, am I right? Minus 2. Yep. So this is our formula. Plug the 3 in. 3. This is our formula. Six over 3. What do we have here? Plus 10. It's plus 10. Is our formula. So see, that's a minus 18. 3 minus 18 plus 10 plus, that's a minus 15 plus 10 plus, that's a minus 5, I'd say. Let's check our answer. minus 5. Okay, in problem 4 and 5, problems at ft equal t minus mg equal t square plus 5. Problem 4 over t. New paper. I got, oh my god, got f t equal t minus 2. I got g t equal 2 square plus 5. What do you want? He wants g composed of f for t. This is how it's written for t. So we got t. Okay. We got g of f of t equal g over f of t equal t minus 2 squared plus 5 equal t minus 2 over t minus 2. I don't remember the formula. Remember the formula a plus b square equal, I don't remember that formula exactly. So we're gonna do it the way, the hard way or the long way. Got t or multiplied by t, that's t squared, t minus 2 t, t minus 2 t, t plus 4, and we got plus 5 here, and we got 2 square minus 4t plus 4 and plus 5 plus 9. So this is it. Equal a square minus 4 minus, I don't know, something like this. I think it's a minus b squared equal a squared minus 2 ab minus, or plus here, plus, I think b plus b squared, I think, b squared. I think it's something like this, the formula. We'll check it now in ChatGPT and over. It's this formula check. Oh my god. Okay. So what are we having? What can we do? And I want the, what can we do here? And what is this? What are we having? Can't we just do some kind of fucking, okay. I don't know, I'm gonna learn this later. So I get this here. I also got this. So let's check our answer. T square, nope, square, and the answer minus r t and that plus 9. Okay, let's check. Problem 5, 5OG. Let's check our formula first. Let's check our formula first in ChatGPT. What we have concluded from our solution. Then no. What do you mean? Okay, let's check. Shall I go? Check this. Is I came up. Okay. Check. That's correct. That's correct. 2ab plus b is one of the standard identities. Okay, what we came up with can actually help in this. So what are we having here? Nope. Here. 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 This is what is you want. This is what? It's G. He wants now. What he wants right now is G out of F out of G. He wants F out of G to the X. F composed with G for X. Well, F G X is, we just flipped what is the outside formula, so we go back here. We got F T minus 2 So we got t squared plus 5 all minus 2, which checks to which equals to t squared plus 5 and minus 2, that's plus 3. So let's go back. T squared plus 3. T squared plus 3. Check, correct. Challenge problem, the graph of the equation y fx and y gx are shown in the grid below. Following best approximates the value of g over 8. So we got fx, over 8. So, wait. So what is actually happening is that what we're having here is f of g means f of gx. So we're getting the gx first. So the gx is 8. The gx is 8. The y is almost 2. It's 2. So the 2, plug it here, and plug it in the y. The 2 is the y. The y is the 2. Yeah, it's the 2. The fx is minus 7, I'd say. Minus 7, right? Minus 7. Two minus 3. 2 is the y-axis. So it can't be this 2. This is the graph. It never touches the 2. It never touches the 2, it's 0. It never touches the 2. Zero. So 8 here equal to, it's equal to, it's equal to, equal to, so 2. Here 2, the y is 2. Where is the y is 2? The y is 2. Where is the x? Never touches there. Wait. If the x is 8, then the y here is actually plug it here. If yep. So if the 8, if the x is 8, the y is 2. The y is 2. So we got the 2. We plug it here, not here. We plug it here if x is 2. 2. Again, the x is 2. The x is 2. Here, answer is minus 3. Minus 3. Minus 3, I would say. Check. Correct. Evaluating composite functions. Next video. 4. Okay, that's it for today. Out of this, that's it for today. Out of this precalculus. Oh my god. Let's do some coding, guys. Let's do this. Bye. Share. Hint 1. Evaluating composite functions. Okay. Didn't master anything. What is this? Is this exerciser? Okay, that's it for today. Thank you very much, you guys.